Hi, this is part two of answering the question, how do you write equations and inequalities? We've looked at what an equation and an inequality is and how to translate them. We've looked at some examples of translating from a verbal statement to an algebraic statement. Okay, so let me clarify something too that I didn't necessarily say. An equation, 2 plus 3 equals 5 is an equation. But we're primarily looking at algebraic equations, meaning there's a variable involved somewhere. Same thing with algebraic inequalities. Okay, so now I want to take what we've looked at in the last video and turn it into some word problems, and then maybe even stretch that a little bit further than what we looked at in the first lesson. So let's look at a word problem. Sarah enrolled in an art class. The enrollment fee for the class was $25. She ended up paying a total of $70 for the enrollment fee and 3 lessons. Write an equation for this situation and use it to determine the cost of 3 lessons. How much did each lesson cost? Now you could figure this out without using an algebraic equation, but it's going to be good practice to do this part here, write an equation for the situation, because there's going to become, as you progress in algebra and geometry, and algebra 2 is algebra, you're going to have to be able to set up equations. So this is good practice, even though this is something that you could probably figure out without necessarily having an equation. Okay, so let's model this situation with an equation. All right, so let's and this comes with practice, but we've got a $25 fee. Okay. And we know that we paid a total of 70 after we paid the cost of the 3 classes. Okay, so let's write T, that's a T, plus 25. That's an expression representing the total cost of the 3 classes plus the $25 enrollment fee, and we know that totals to 70. Okay, so we could do this a couple ways. We could say, okay, what plus 25 gives me 70, or let's get a little ahead of ourselves. Later on in the course, we're going to spend more time on solving algebraic equations, but you've probably seen enough to know how to solve a simple equation like this. We want to get the variable by itself, by undoing what's being done to the variable. So in this case, 25 is being added to t, so I'm going to undo that by doing the opposite. Opposite of adding is subtracting. What I do to one side of the equation, I have to do the opposite side, so I'm going to subtract 25 here as well. So t, 25 minus 25, positive 25 minus 25 is 0, so that just leaves me with t. And 70 minus 25 is what? 45. Okay, so the total cost of the 3 lessons is $45. And then the last question, how much did each lesson cost? Well, you know that there was 3 lessons. Okay, so I'm going to divide 45 by 3, okay, and that would give me 15. Let's again represent that with an equation. So 45 divided by, let's say, C, the number of classes, is equal to, wait, hold on a second. Yes, so 45 divided by the number of classes is going to equal what? It's going to equal, let me do this a little bit differently. So 45 divided by 3, because we have 3 classes, is going to equal $15. So each class, C, is equal to $15. Okay, so hopefully this part wasn't too confusing. We could have done this a couple different ways. I could have just said, I should have maybe put 45 divided by 3 is equal to C. Okay. What's another way we could have done that? We also know that 3 times the cost of one class is equal to 45. And we could say, whoops. And we could say, what times 3 is equal to 45? Well, if we divide both sides by 3, 45 divided by 3 is 15. Okay, so the cost of one class is 15. Okay, so I'm getting a little bit ahead of myself as far as requiring you to solve these equations, but okay, this is good practice. I'm sure you could do it anyways. Okay, so now let's look at an example with an inequality. Tyler would like to make no less than $610 selling coffee mugs online. If he sells 28 mugs for $22 each, will he achieve his goal? What are we dealing with here? Are we dealing with an equation or an inequality? Okay, do we see the word is in here? We don't. We see no less than. So we're dealing with an inequality. So he would like to make no less than $610. Could he make $610? Yes, he could. Okay, so we're looking at, less than or equal to or greater than equal to. Okay, no less than. So that means he could have 610. If he sells 28 mugs for $22 each, will he achieve his goal? So again, let's just practice representing an inequality. We could represent this as 22 times m, let's let m represent the number of mugs, has to be less than or equal to or greater than equal to 610. What does it have to be? Okay, no less than. So it's got to be greater than or equal to 610. Okay, if it's no less than, then it has to be let's say if it's 609, then it's less than 610. So it's got to be, this value has to be greater than or equal to 610. Okay, so 22 times the number of mugs, which in this case, so this would be an inequality representing this situation, but we're also given the number of mugs in this case. So 22, and I'm going to use parentheses for multiplication, 22 times 28, is it greater than or equal to 610? Is it greater than or equal to 610? If so, the question is, will he achieve his goal by selling 28 mugs? Okay, and so is 22 times 28, is it greater than or equal to 600? If you multiply them together, you find that 622 times 28 is 616. So 616 is greater than 610. So what do we do in this problem? I used an inequality to represent the situation, even though we didn't need to because the number of mugs was given, but it's good practice just translating. And so then we also answered the question if he sells 28 mugs. So technically for this question I could have done without this, but I was just trying to practice translating. All right, so that's a little bit of a couple examples of translating and solving for a solution to both an equation and an inequality.